Airtight recessed cans are required in specific scenarios to ensure safety and prevent fire hazards. Firstly, when installed in a ceiling with insulation, airtight recessed cans are necessary. Recessed cans generate heat, and this heat can potentially ignite nearby insulation. An airtight can prevent hot air from escaping and coming into contact with the insulation, mitigating the risk of fire. Secondly, insulation in the ceiling with combustible materials also necessitates the use of airtight recessed cans. Combustible materials, such as wood or paper, are easily ignited when exposed to heat. An airtight can act as a barrier, preventing heat from escaping and igniting these materials. Thirdly, in bathrooms or other moisture-prone areas, airtight recessed cans are crucial. Moisture can damage recessed cans, leading to malfunctions and potential electrical hazards. An airtight can prevent moisture from entering the can, protecting the components and ensuring safe operation. Fourthly, installation in commercial buildings often requires airtight recessed cans due to strict fire safety codes. These codes are in place to protect occupants and property from fire-related incidents. Choosing the correct recessed lighting involves several considerations to ensure safety, energy efficiency, and desired lighting effect. Here are some key factors to keep in mind. Consider the purpose of the lighting in the space. General lighting provides overall illumination, task lighting focuses on specific work areas, and accent lighting highlights particular features. Determine the appropriate light output, measured in lumens, needed for the space. Different areas require different levels of brightness. For example, a kitchen might need brighter light than a bedroom. Select the appropriate color temperature, measured in Kelvin. Warm air temperatures like 2700 Kelvin to 3000 Kelvin create a cozy atmosphere, while cooler temperatures like 4000 Kelvin to 5000 Kelvin provide a more energetic feel. Consider the energy efficiency of the light source. Light-emitting diode, or LED, lights are highly energy efficient and have a long lifespan compared to incandescent or halogen bulbs. Choose the appropriate type of recessed housing. Insulated ceiling, or IC, rated housings are designed for direct contact with insulation, while non-IC rated housings require a 3-inch clearance from insulation. Consider the size and shape of the recessed can to ensure it fits properly in the ceiling and provides the desired aesthetic. Choose the appropriate trim style to match the decor of the space. Options include baffle trims, reflector trims, and adjustable trims. Consider the beam angle of the light to achieve the desired lighting effect. Narrow beam angles provide focused light, while wider beam angles provide more general illumination. Check local building codes and regulations to ensure compliance with safety standards. For example, certain areas may require airtight or moisture-resistant fixtures. When working with electrical wiring, always prioritize safety. Here are some essential safety precautions to follow. Always turn off the power at the circuit breaker before working on any electrical wiring. Use insulated tools to prevent electric shock. Wear safety glasses to protect your eyes from debris. Never work on electrical wiring when you are wet or standing in water. Inspect wiring for damage, such as frayed insulation or loose connections, before starting any work. Use wire connectors and electrical tape to properly insulate and secure connections. If you are unsure about any aspect of electrical wiring, consult a qualified electrician. Following these safety precautions can help prevent electrical accidents and ensure a safe working environment. Electrical boxes serve as protective enclosures for electrical connections, providing safety and organization. Different types of electrical boxes are designed for specific applications. Here are some common types of electrical boxes. Outlet boxes are used to house electrical outlets and switches. Junction boxes are used to connect multiple wires together. Ceiling boxes are designed to support light fixtures and ceiling fans. Weatherproof boxes are used for outdoor applications to protect against moisture and the elements. Angle boxes can be joined together to accommodate multiple devices. Choosing the right type of electrical box is essential for ensuring safe and compliant electrical installations. Consider the number and size of wires that need to be accommodated when selecting a box. Ensure that the box is properly secured to the wall or ceiling. Use appropriate connectors and fittings to ensure secure and weatherproof connections. Always follow local electrical codes and regulations when installing electrical boxes. By selecting and installing electrical boxes correctly, you can ensure a safe and reliable electrical system. Grounding electrical systems is essential for safety, providing a path for fault current to return to the source and prevent electrical shock hazards. Here are some key aspects of grounding electrical systems. Grounding involves connecting electrical equipment and systems to the earth through a grounding electrode. This creates a low impedance path for fault current to flow back to the source, tripping the circuit breaker or fuse into energizing the circuit. Grounding helps to stabilize voltage levels, reducing the risk of voltage fluctuations and electrical noise. Grounding also provides a path for static electricity to dissipate, preventing damage to sensitive electronic equipment. Different types of grounding systems are used depending on the application, including equipment grounding, system grounding, and static grounding. Equipment grounding involves connecting the metal enclosures of electrical equipment to ground to provide a path for fault current. System grounding involves grounding the neutral conductor of the electrical system to provide a reference point for voltage. Static grounding involves grounding equipment to prevent the buildup of static electricity. Proper grounding is essential for ensuring the safety and reliability of electrical systems. Always follow local electrical codes and regulations when installing grounding systems. Use appropriate grounding conductors and connectors to ensure secure and effective grounding. Regularly inspect grounding systems to ensure they are in good condition. By implementing effective grounding practices, you can minimize the risk of electrical hazards and protect people and property. Electrical conduit provides a protective pathway for electrical wiring, safeguarding it from damage, moisture, and other environmental factors. Different types of electrical conduit are available, each suited for specific applications. Rigid metal conduit, or RMC, is a heavy-duty conduit made of steel or aluminum, providing excellent protection against physical damage. Intermediate metal conduit, or IMC, is a thinner-walled steel conduit that offers good protection at a lower cost than RMC. Electrical metallic tubing, or IMT, is a lightweight steel conduit that is easy to bend and install, commonly used for indoor applications. Flexible metal conduit, or FMC, is a flexible conduit that allows for movement and vibration, often used for connecting equipment. Rigid polyvinyl chloride, or PVC, conduit is a non-metallic conduit that is resistant to corrosion, suitable for underground and wet locations. Selecting the right type of electrical conduit depends on the specific requirements of the application. Consider the environment, the type of wiring being protected, and the applicable electrical codes. Ensure that the conduit is properly installed and supported. Use appropriate fittings and connectors to ensure secure and weatherproof connections. By choosing and installing electrical conduits correctly, you can protect electrical wiring and ensure a safe and reliable electrical system. Wiring methods refer to the various ways in which electrical conductors are installed and protected within a building or structure. Different wiring methods are used depending on the application, the environment, and the applicable electrical codes. Non-metallic sheathed cable, or NM cable, also known as Romex, is a common type of wiring used for residential applications, consisting of insulated conductors enclosed in a non-metallic sheath. Armored cable, or AC cable, also known as BX cable, is a type of wiring that consists of insulated conductors enclosed in a flexible metal jacket. Metal-clad cable, or MC cable, is similar to AC cable but has a grounding conductor and is suitable for a wider range of applications. Conduit wiring involves installing conductors inside electrical conduit for protection. Cable tray wiring involves supporting conductors on open cable trays commonly used in industrial and commercial applications. Selecting the appropriate wiring method depends on various factors, including the type of building, the type of electrical system, and the environmental conditions. Always follow local electrical codes and regulations when installing electrical wiring. Ensure that wiring is properly supported and protected. Use appropriate connectors and fittings to ensure secure and reliable connections. By choosing and installing wiring methods correctly, you can ensure a safe and compliant electrical system. Overcurrent protection devices, such as circuit breakers and fuses, are essential components of electrical systems, designed to protect against overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. Circuit breakers are resettable devices that trip open when an overcurrent condition is detected. They can be manually reset after the fault has been cleared. Fuses are one-time use devices that melt and open the circuit when an overcurrent condition occurs. They must be replaced after they have blown. Circuit breakers and fuses are rated in amps, indicating the maximum amount of current they can safely carry. Selecting the appropriate overcurrent protection device depends on the size of the circuit and the type of equipment being protected. It is crucial to choose a device with a rating that is appropriate for the circuit to prevent nuisance tripping or failure to protect against overcurrents. Overcurrent protection devices should be installed in readily accessible locations and properly labeled. Regularly inspect overcurrent protection devices to ensure they are in good working condition. By using overcurrent protection devices correctly, you can protect electrical systems from damage and ensure a safe electrical environment. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect against electrical shock by monitoring the current flowing in a circuit. If a ground fault is detected, meaning current is leaking outside of the intended circuit path, the GFCI quickly interrupts the power, preventing a potentially fatal shock. GFCIs are commonly used in areas where water is present, such as bathrooms, kitchens, and outdoor locations. They are also required in certain other locations by electrical codes. GFCIs work by comparing the current flowing in the hot and neutral conductors of a circuit. If there is a difference of more than a few milliamps, indicating a ground fault, the GFCI trips and interrupts the power. GFCIs are available in various forms, including receptacle-type GFCIs that replace standard electrical outlets, circuit breaker-type GFCIs that provide protection for an entire circuit, and portable GFCIs that can be plugged into existing outlets. Regularly test GFCIs to ensure they are functioning properly. The test button on the GFCI should be pressed periodically to simulate a ground fault and verify that the device trips. If a GFCI fails to trip when tested, it should be replaced immediately. By using GFCIs in appropriate locations and testing them regularly, you can significantly reduce the risk of electrical shock. Arc fault circuit interrupters, or ARCs, are devices designed to protect against fires caused by electrical arcs. Arcs are dangerous electrical discharges that can occur when wires are damaged, connections are loose, or insulation is failing. ARCs detect these arc faults and quickly interrupt the power, preventing the arc from igniting nearby materials and causing a fire. ARCs are required by electrical codes in many areas, particularly in bedrooms and other areas where people sleep. They are designed to distinguish between normal arcs, such as those produced by switches and motors, and dangerous arc faults that can cause fires. ARCs work by monitoring the electrical waveform for characteristics that indicate an arc fault. When an arc fault is detected, the ARC trips and interrupts the power. ARCs are available in circuit breaker type and outlet type configurations. Regularly test ARCs to ensure they are functioning properly. The test button on the ARC should be pressed periodically to simulate an arc fault and verify that the device trips. If an ARC fails to trip when tested, it should be replaced immediately. By using ARCs in appropriate locations and testing them regularly, you can significantly reduce the risk of electrical fires. Surge protective devices, or SPDs, are designed to protect electrical equipment from voltage surges, which are sudden and transient increases in voltage that can damage sensitive electronics. Surges can be caused by lightning strikes, power grid switching, or internal equipment malfunctions. SPD work by diverting excess voltage away from protected equipment and safely dissipating it. They are available in various forms, including whole-house surge protectors that protect all electrical equipment in a building, and point-of-view surge protectors that protect individual devices. SPD are rated by their surge current capacity, which indicates the amount of surge current they can safely handle. They are also rated by their voltage protection rating, which indicates the maximum voltage that will be allowed to pass through to protected equipment. SPD should be installed in accordance with manufacturer's instructions and electrical codes. Whole house surge protectors are typically installed at the main electrical panel, while point-of-use surge protectors are plugged into electrical outlets. Regularly inspect SPD to ensure they are functioning properly. Some SPD have indicator lights that show whether they are still providing protection. If an SPD has been subjected to a large surge, it may need to be replaced. By using SPD, you can protect valuable electrical equipment from damage caused by voltage surges. Electrical panels, also known as breaker boxes or load centers, are distribution points for electrical power in a building. They contain circuit breakers or fuses that protect individual circuits from overcurrents. Electrical panels are typically located in an accessible area such as a basement, garage, or utility room. Electrical panels are sized according to the electrical load of the building, with larger buildings requiring larger panels. Electrical panels should be properly labeled to indicate the circuits they serve. Circuit breakers or fuses should be clearly labeled with the areas or equipment they control. Electrical panels should be kept clean and free of obstruction. Loose wires, debris, and other materials can create fire hazards. Regularly inspect electrical panels for signs of damage such as rust, corrosion, or overheating. If any problems are detected, consult a qualified electrician. Electrical panels should be installed and maintained in accordance with electrical codes. Working on electrical panels can be dangerous and should only be performed by qualified electricians. Proper grounding and bonding are essential for safety. By properly maintaining electrical panels, you can ensure a safe and reliable electrical system. Electrical safety is paramount when working with electrical systems. Always follow these safety guidelines. Always de-energize circuits before working on them. Turn off the power at the circuit breaker or fuse box. Use insulated tools to prevent electric shock. Wear appropriate personal protective equipment, such as safety glasses and gloves. Never work on electrical equipment when you are wet or standing in water. Inspect electrical equipment for damage before use. Replace damaged cords, plugs, and other components. Follow electrical codes and regulations. Obtain necessary permits and inspections. If you are unsure about any aspect of electrical work, consult a qualified electrician. Electrical work can be dangerous and should only be performed by qualified individuals. Never overload circuits. Avoid using extension cords and power strips as permanent wiring solutions. Use ground fault circuit interrupters, or GFCIs, in areas where water is present. Test GFCIs regularly to ensure they are functioning properly. Use arc fault circuit interrupters, or RFCIs, to protect against electrical fires. Test RFCIs regularly to ensure they are functioning properly. Install surge protective devices, or SPDs, to protect against voltage surges. By following these electrical safety guidelines, you can minimize the risk of electrical hazards and ensure a safe electrical environment. Understanding electrical codes is essential for ensuring safe and compliant electrical installations. Electrical codes are sets of regulations that govern the design, installation, and maintenance of electrical systems. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. Electrical codes are developed and updated by organizations such as the National Fire Protection Association, or NFPA. Electrical codes cover a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. Electrical codes are enforced by local and state authorities. Permits and inspections are required for many types of electrical work. It is important to consult the latest version of the electrical code for your area. Electrical codes are complex and can be difficult to understand. Consult a qualified electrician for assistance with interpreting and applying electrical codes. Electrical codes are designed to protect people and property from electrical hazards. Following electrical codes is essential for ensuring a safe electrical environment. Electrical codes are constantly evolving to reflect new technologies and safety practices. Stay up to date on the latest changes to electrical codes. Electrical codes are not a substitute for good workmanship. Electrical work should be performed by qualified individuals who are knowledgeable and experienced. By understanding and following electrical codes, you can ensure that your electrical installations are safe and compliant. Understanding voltage drop is important for ensuring efficient and reliable electrical system performance. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction, lights to dim, and motors to overheat. Voltage drop is affected by several factors, including the length of the conductor, the size of the conductor, the current flowing through the conductor, and the temperature of the conductor. Longer conductors, smaller conductors, higher currents, and higher temperatures all increase voltage drop. Voltage drop can be calculated using Ohm's law and other electrical formulas. Electrical codes typically limit the amount of voltage drop allowed in branch circuits and feeders. To minimize voltage drop, use larger conductors, shorter conductor lengths, and lower currents. Consider using parallel conductors to reduce voltage drop in long runs. Use voltage drop calculators to determine the appropriate conductor size for a given application. Regularly inspect electrical systems for signs of voltage drop, such as dim lights or malfunctioning equipment. Address voltage drop issues promptly to prevent further problems. By understanding and managing voltage drop, you can ensure efficient and reliable electrical system performance. Conducting electrical load calculations is essential for determining the appropriate size of electrical equipment and wiring. The electrical load calculations involve estimating the total amount of electrical power that will be used in a building or system. Load calculations are used to determine the size of the service entrance, the size of the electrical panel, the size of the branch circuits, and the size of the overcurrent protection devices. The electrical load calculations are based on various factors, including the square footage of the building, the type of occupancy, the types of electrical loads, and the diversity of the loads. The National Electrical Code, or NEC, provides detailed guidelines for performing electrical load calculations. Electrical load calculations involve adding up the continuous loads, the non-continuous loads, and the demand factors. Continuous loads are loads that operate for 3 hours or more at a time. Non-continuous loads are loads that operate for less than 3 hours at a time. Demand factors are factors that reduce the calculated load to account for the fact that not all loads will be operating at the same time. Electrical load calculations should be performed by qualified individuals who are knowledgeable about electrical codes and practices. Accurate load calculations are essential for ensuring a safe and reliable electrical system. Undersized equipment and wiring can overheat and cause fires. Oversized equipment and wiring can be unnecessarily expensive. By performing accurate electrical load calculations, you can ensure that your electrical system is properly sized for your needs. Understanding the different types of electrical diagrams is essential for designing, installing, and troubleshooting electrical systems. Electrical diagrams are visual representations of electrical circuits and systems. There are several types of electrical diagrams, including single-line diagrams, schematic diagrams, wiring diagrams, and block diagrams. Single-line diagrams show the main components of an electrical system and their connections, using simplified symbols. Schematic diagrams show the details of an electrical circuit, including all of the components and their connections. Wiring diagrams show the physical layout of the wires and components in an electrical system. Block diagrams show the functional relationships between different parts of an electrical system. Electrical diagrams are used by electricians, engineers, and other professionals to understand and work on electrical systems. Electrical diagrams should be clear, accurate, and easy to understand. Electrical diagrams should be drawn in accordance with industry standards. Understanding electrical diagrams is essential for troubleshooting electrical problems. By studying the electrical diagrams, you can identify the cause of the problem and develop a solution. Electrical diagrams are valuable tools for anyone working with electrical systems. Understanding how to read and interpret electrical diagrams is a valuable skill for electricians, engineers, and homeowners. Electrical testing and measurement are essential for ensuring the safety and proper functioning of electrical systems. Electrical testing and measurement involve using various instruments to measure electrical parameters such as voltage, current, resistance, and continuity. Common electrical testing and measurement instruments include multimeters, clamp meters, insulation testers, and circuit testers. Multimeters are used to measure voltage, current, resistance, and continuity. Clamp meters are used to measure current without having to disconnect the circuit. Insulation testers, also known as megometers, are used to measure the insulation resistance of wires and equipment. Circuit testers are used to verify that circuits are properly wired and energized. Electrical testing and measurement should be performed by qualified individuals who are knowledgeable about electrical safety and testing procedures. Always follow safety precautions when working with electrical equipment. Energize circuits before testing whenever possible. Use insulated tools and wear appropriate personal protective equipment. Regularly calibrate electrical testing and measurement instruments to ensure accuracy. Keep electrical testing and measurement instruments clean and in good working condition. Electrical testing and measurement are essential for troubleshooting electrical problems. By measuring electrical parameters, you can identify the cause of the problem and develop a solution. Electrical testing and measurement are also used to verify that electrical systems are installed and functioning properly. Regular electrical testing and measurement can help prevent electrical hazards and ensure the safety of people and property.